western Pacific Ocean stretches from Thailand to the Solomon Islands and from Japan to Australia. Nowhere else in the world are there as many different types of coral fish as in these waters. Amid this vast expanse of water lies a tiny island state, Palau. The distance to the nearest mainland is over 1,000 kilometers, and therefore overfishing and water pollution have caused far less damage to the Palau archipelago than in most Pacific regions. Gigantic fish schools swim among the coral reefs where clean water and strong currents offer them abundant nourishment. The underwater world of Palau is full of life and color, one of the last natural paradises on Earth. However, this paradise is now in danger. An aquarium full of fish, the relatives of which live only a few meters away in the sea. No, it isn't a joke. It's a project of the Palau International Coral Reef Center. The workplace of Lolita Penland is brand new and costs some $10 million, a joint effort by Japan, the US, and the government of Palau. The issue here is the protection of the sea, a task that no country alone can come to grips with. Lolita spends the biggest part of her day in the lab of the Coral Center. She analyzes water samples and documents the results. She breeds algae and plankton cultures in order to study the interaction between water quality and growth. She analyzes the effects of pollutants on microorganisms and the resistance of the tiny sea inhabitants to fluctuations in temperature. Everyday life in the lab. Lolita is in charge of the Coral Center Research Department together with a colleague from Japan. She studied in the USA, worked for other institutes before she got the job in the center, and is the only marine biologist in the country who comes from here too. A real Palauan, only 26 years old.
So right now I'm looking at the microalgae under the microscope. We're growing about 6 different species. This one is Isochryses, and this algae we grow to feed the larvae of fish and invertebrates that we keep in the aquarium.
Lolita comes to do her job here every morning out of a sense of duty. To her it is a rather tiresome task, for what she loves doing is field research out at sea, not spending her days in the air-conditioned atmosphere of the lab. Her colleague Ken is a little better off. He may not be swimming in the sea, but it is at least in the water, removing weeds from the aquarium. Big pools like this are used by the scientists as a more practical mini version of a coral reef. Here they can observe through the glass many sea animals and plants which otherwise they would have to try and find in the open sea. Moreover, they can entirely control the environmental impacts within an aquarium, and so learn a lot about the links in a complicated ecosystem at the same time.
Okay, so what Ken is showing us here is the 16 monitoring sites that PICRC wants to investigate. So the kind of issues we're going to be looking at is comparing conservation and non-conservation, tourism impacted and non-tourism impacted, and development sites. And what we're trying to do is assess what these impacts have on our coral reefs and our marine resources, so that we can educate people and policymakers about maybe some of the things that humans do affect our coral reefs.
In the afternoon, Lolita can finally do what she loves most, field work. Together with her colleague Ken, she leaves the Coral Center and sets off to a group of coral reefs in the sea off the Palau Islands. They examine the corals' rate of growth, what environmental forces affect them, and the consequences these might have on the sea flora and fauna. the way to the corals, the scientists discuss their mission for today. Their job is to collect data from an area that was very badly affected by the El Niño phenomenon in 1998. Ken has meticulously marked the grid squares to be explored on a sea chart. In order to consolidate their study and make it convincing, Lolita and Ken must inspect exactly the same grid squares underwater as those on the chart.
Coral cover was high, according to the
First of all, the current is measured, as it has tremendous influence on the health of a coral. The current brings oxygen and nourishment to the coral. Along with the velocity at which the water moves, this device measures its temperature and other data. Only if this data is collected regularly over a period of several years at exactly the same locations will the scientists receive meaningful information. Then, Lolita and Ken are ready to dive. Lolita collects coral pieces that she will examine in the lab and place into the aquarium later. Meanwhile, Ken films the reefs with his video camera. He does that every few months in order to document their growth rate. And growth is of utmost importance here, since many corals are already dead. The disease which many coral reefs worldwide suffer from is called coral bleaching. The main problem in this case is the water temperature. Through the El Niño phenomenon and other influences caused by man, the average temperature on Earth has increased, and so has the water temperature. Corals, however, are so extremely sensitive to fluctuations in temperature that even small changes cause them to die. A dead coral reef is something like a forest without trees. Only a few animals can survive in such an environment. Palau, thanks to its remote geographical position and the above-average quality of the water surrounding it, has not been affected in a particularly bad way. On the Maldives or the Seychelles, the consequences of coral bleaching are devastating. Stony corals like these grow very slowly, a few millimeters a year at the most. This is the reason why it takes a dead reef so long to recover from the consequences of an environmental disaster such as El Niño. Soft corals and sea anemones, also called actiniaria, grow much faster. They are the first to settle again after the natural climatic phenomenon has worn off. Lolita and Ken examine every animal, every sponge, every new soft coral, every sea anemone painstakingly. This sea anemone has just caught a small fish. The fish is still alive, but has almost disappeared into the mouth of the sea anemone. Lolita and Ken's underwater job is done for today, but as long as there is some air left in the bottle, the marine biologists do not emerge. The underwater world is too fascinating for them to leave behind. They make use of every second, every ounce of air. Palau's Rock Islands are a World Natural Heritage Site. They are under the special protection of the United Nations. In spite of that, little is known about them. Even their exact position is disputed sometimes.
Today in Palau, we deal with Japanese charts from 1927. Those charts were drawn by the Japanese using sextants, a very old method. Today, in order to provide much better understanding of the reef and its position, we use GPS, a much modern technique, in order to relocate the reef, redraw it, using computers to provide a three-dimensional dive site of the reefs.
Nawat Bonovsky's program is called D-Log and will be made available to both scientists and scuba divers. Scientists are hoping to gain a more precise understanding of the changing currents from the sea charts. What is more, the currents have a significant effect on the growth of the corals, so somehow everything is linked underwater, but it is difficult to understand it all. Before Nawat can program his virtual underwater world on his computer, he must still dive the old-fashioned way in order to survey the reefs. On the way there, he encounters a school of barracudas. They are drifting in a circle in the current, lurking for quarry. Nawat swims along the roof of the reef. His way leads along gorges and canyons. The corals have needed thousands, sometimes millions of years to form this tremendous landscape. They keep growing year after year, millimeter by millimeter, and Nawat must measure everything in detail. The size of the individual cave chambers, the width and depth of the connecting tunnels must be measured exactly before an accurate three-dimensional chart can be constructed.
Divers and non-divers can enter this program and explore the underwater beauty of Palau. They can go and see wrecks, walls and caverns, three-dimensional. They can rotate it, they can go in and out and experience the unique diving of Palau.
The Chandelier Cave, for example. Some of the small rock islands of Palau are hollow inside. Nawat swims from the sea straight into the heart of the island. The peaks of stalactites jutting out in the water are dangerous, but Nawat knows his way through the labyrinth very well. He also knows the way to this ship nearby, the Helmet Wreck. It is one of many shipwrecks that can be found on the seabed around Palau. Like the Helmet Wreck, most of them are Japanese warships sunk by American troops during the Second World War. The Japanese had used Palau as a military outpost in order to stop the advance of the Americans. Nevertheless, the U.S. Navy was stronger, and this is why half a century later, around 80 Japanese wrecks lie on the bottom of the sea. Nawat's measuring and inspection of all these wrecks is a job that involves risk. These shipwrecks here are as dangerous as depth bombs. No one knows how many of them are live and could still explode. Nawat documents exactly which wreck lies where and what can still be found on board, from depth charges to cannons on the former decks. Divers or clearance crews will then have an easier job finding their way through the explosive scrap heap, thanks to the accurate computerized presentation of the shipwrecks. Navot moves on and encounters several sharks along the way. This is an area that is abundant in fish, and gray reef sharks glide up and down in the current the whole day. Sharks are one of the most successful models of evolution and have therefore hardly changed in 300 million years. With their sophisticated sensory organs, they register noises, shock waves, electric signals, and scents over huge distances. In addition, many shark species have also extremely good eyesight. They are the perfect hunters. A tuna swims past. It is also a successful hunter, as one can easily recognize by its sharp teeth. Only a few meters away, Navot passes another hunter, an eagle ray. Despite its impressive span of 2.5 meters, an eagle ray only feeds on very small animals, crustaceans and mollusks it picks up from the ground. Meanwhile, Navot has reached an underwater cave system, the next project for his virtual marine world. The numerous grottos and caves in the reef system of Palau attract divers from around the world. But the adventure of exploring them is full of hidden dangers. Many scuba divers have been lost in the virtually endless labyrinth of tunnels, passageways, gorges, and grottos. There have been a number of fatal accidents over the years. Perhaps Navot's underwater maps can help, so that such misfortunes can be avoided one day. For if divers study on the computer display how to get out again before they venture into the caves for the first time, they will possibly find it easier to make their way through the labyrinth in case of an emergency. Maybe the D-Log program can even save lives. Navot makes some last notes. Then it is time for him to return to the surface and back to his computer. Meanwhile, in the Coral Reef Center, Lolita has begun the evaluation of her underwater expeditions. Part of the job is the observation and cataloging of all pieces that she has collected in the open sea. Some have to be analyzed in the lab, while others shall refresh the coral population in the aquariums of the research station.
So these are the coral specimens you saw us collect out in the field, and right now I'm sorting them and preparing them before we put them in the quarantine tanks. And they usually have to stay in the quarantine tanks about a month so we can assess if they carry diseases or if they're healthy, and then we can introduce them to the exhibits.
One single plant or animal carrying a disease would be enough to infect the entire mini reef and destroy everything that has grown in the big aquarium. These quarantine tanks are therefore very important. In this basin, Lolita can study the growth rate of corals. How do, for example, free-floating animals behave? Or can man positively influence the coral growth so as to minimize the result of weather fluctuations and environmental disasters? There are many unsolved issues. Many years of research will pass before scientists can answer the question as to how the complicated ecosystem of the coral reef functions. But the environment does not have very much time. Therefore, a few houses down, these men work on more immediate programs for the protection of the unique seaworld of Palau, the Water Rangers.
What you are looking now is the Republic of Palau, and our area of responsibility for the Coral State Rangers and I are starting from the Gaby Bridge all the way down just to the north of Pilalio. And our responsibility is to enforce all environmental laws within this area and at the same time do conservation work.
On this morning, Adalbert and his rangers prepare for an underwater mission. A newly designed nature reserve must be closed to boat traffic. To this purpose, these buoys need to be anchored around the entire area. Adalbert supervises his team's work from his speedboat. First of all, the men must find the right place to anchor the new buoys. Once a location has been found, the divers must go in. This is where the buoy has to be fixed. It must withstand the Pacific storms and the salt water and last as many years as possible. The men must bore a deep hole into the coral reef with this special drill. Drilling is not an easy job underwater. Fortunately, everything works out fine. A colleague brings the cement to anchor the buoy to the sea bottom. The borehole is filled with common cement. Amazingly, it also hardens underwater. Now the men must drive a steel hook into the cement while it is still soft, and the most difficult part of their job is done. Time to surface again. Two hours later, in the headquarters of the Palau Rangers in the capital, Koror. The patrol boat crews are briefed. The men on their speedboats drive around the nature reserves every day, searching for environmental polluters, unregistered fishing boats, or divers' ships without license. Harry Bleason and Rengashel Delutosh have been a team for 2 years. 2 out of a total of 12 rangers responsible for nature conservation at sea. Part of their job is the supervision of a maritime cleaning crew that fishes waste out of the sea and searches even the most secluded beaches for washed-up debris.
Aurora Coral State Beach Boys. Already rabek shields lora lagi del alol clean alol mesa ge rogul gomin nia sebeto melia environment isingin aksyon ol. Okay.
Ranger Harry plans and supervises the assignments of the beach boys. Once they are finished with cleaning one beach, they move on to the next one. 70 islands, a unique group of islands and the oldest maritime nature reserve in the entire Pacific. No one is allowed to set foot on or be anywhere near these islands, except, of course, the rangers patrolling them. In this area, turtles lay their eggs undisturbed. Rare fish swim between the islands, and the vegetation has not been spoiled by man for half a century now. On the edge of the nature reserve, Harry and Rengeshel spot an offender. His name is Abraham Tattingal. He is now in trouble. This is a difficult job because we Palauans practically live in the sea. Everyone could always go wherever they wanted. People are only just beginning to understand that this is not possible anymore. Abraham must pay a fine of about $50 US, a lot of money to him. But he is already calmer. After all, he is a Palauan and everybody knows everyone else. And even when there is an argument, chewing a betel nut together afterwards helps to restore the old cordiality. On the next morning, back in the Coral Center, school children learn at the saltwater basins how the marine ecosystem works. In a country that consists of hundreds of islands, of course, such educational activities are of great importance.
Normally these kids don't have a chance to see because they can't scuba dive and they can't spend hours in the water. So these exhibits show them very quickly how wonderful their environment is. And secondly, as a researcher, it's a great benefit to have the specimen that we study here in the tanks so that we don't have to keep going out into the field to study the subjects.
Lolita and her scientist colleagues in the Coral Center. The rangers who make sure everything is all right at sea every day. Or Navat, the man who explores and charts wrecks and caves. They all have the same goal. They want the underwater world of Palau to remain the way it is.